All right, ladies and gentlemen, here is your warm-up. What you need to do is turn to page 27 of your book, and I will just add that here. Turn to page 27 in your notes and complete this warm-up. As you are writing these questions into your notes, I just want to let you know that there are going to be some examples today where I ask you to pause to complete the problem and to then move forward. As you move forward, I will have the answers to the problems. However, you can not have only the answers on your paper. I expect to see the work shown. So please make sure that as you are moving forward, that you are showing your work. Otherwise, you are going to have to go back and redo that part of the problem because you will have to turn this in at the end. All right, so go ahead. If you have these problems written down in your warm-up, hit pause, take some time to solve them, and then come on back and see if you got the right answers. These are the correct answers. Again, you need to have your work shown in order to get credit for this tomorrow. So if you did not show your work, hit pause again at this point in time. Make sure you show the railroad tracks and everything that you were doing. Yes, it is okay to use a calculator to do the computation, but I do need to see where you are telling me what you're subtracting, what you're multiplying, and what you're dividing. All right. So at the end of this lesson, I will give you the answers to your homework from yesterday, so please make sure that you have that nearby as well. We're still working on one-step equations for today. We're going to talk about how do I solve for a variable. And so what we need to do is the same steps that we have been doing. First, you're going to draw your train tracks to separate the different sides of your equations. You are going to complete the opposite operation. And so for part of this is you're going to ask yourself those 4 questions. What am I solving for? What is bothering it? How is it bothering it? And how do I get it by itself? What is the inverse? Make sure you do the same thing to the other side and then check your answer. It is wise to check your answer to make sure you're getting the correct answer. All right, here we go. So what we did yesterday is we had integers. Integers, again, don't have any decimals and don't have any fractions. When they have the decimals and the fractions, we've gone into numbers that are only rational, that they don't fit in any other category. So right now we're dealing with how do I solve one-step equations with rational numbers in there. Steps are still the same. The very first thing I'm going to do is draw my railroad tracks. Then I'm going to ask myself those 4 questions. What am I solving for? I am solving for this A. What is bothering it? This 7.2. The next question is the most important. How is this 7.2 bothering this A? It's bothering it by multiplying. So the inverse then, the opposite operation that I want to complete, the opposite of multiplying is to divide. Remember, I divide by exactly what we said was bothering A. You said A was being bothered by 7.2, so I need to divide both sides by 7.2. This is where it makes my gigantic 1. And then we can fill it in. But whatever I do to one side, I have to do to the other side. So this side would also be divided by 7.2. My A would be left over. And you can put the 1 in front of it if you want to. However, it is not necessary. And then I'm going to divide these. And I can take out my calculator and divide them if I need to. I know a negative divided by a positive is a negative, and I think that this would end up being 1/2. Because it is late while I'm making this video, I am going to clarify, and I'm just going to take 3.6 and I'm going to divide it by 7.2 and just see if I get 1/2, and I do. All right, so we're good to go. That gave me 1/2. So again, ask yourself those 4 questions. What am I solving for? What's bothering it? The 7.2. How? By multiplying. The inverse is to divide. Whatever I do to one side, do to the other, and get the answer. If you did not take the time to show your work for that problem, go ahead and hit pause and fill it in. Here's the second problem that you have on your paper. The second problem you have, again, What am I solving for? The a. What is bothering my a? The a is being bothered by this 1.44. How is the 1.44 bothering it? Well, it's bothering it by dividing. So the opposite of dividing, the inverse operation, is to multiply by 1.44. 1.44. Whatever I do to one side, I need to do to the other side. 1.44. There are no negatives here to worry about. I can just work with what I have. And I am going to have to pull out the calculator here for this one. So I'm going to have 1.44 times 1.2. And it's going to give me an answer of 1.728. 1.728. So I know that my answer is 1.728, and that equals A. Remember, it's always a good idea to go back and check your work just to make sure. So I could take this and put it up here for A, and then I would have 1.728 that would be divided by 1.44, and I would just hope that that answer would equal 1.2 when I solved it. All right. So those were the two problems that I was going to show an example. Or notice how it's all the same steps that we took yesterday. The problems just have decimals in them. I'm going to show you two problems here. I want you to fill both of these problems in on your paper and then take time to solve them. After you are done solving them, the next screen is just going to give you the answers. Again, in order to turn this in, you have to have work shown with railroad tracks and what you multiplied or divided each side by. Go ahead and hit pause now. All right, so the answers that you wanted for the first one, you should have x equals -8. And the second one, you should have m equals 27.6. So occasionally there are going to be some fraction problems. And when I am solving those fraction problems, we need to remember some of the skills from last year. One of the skills that you need to remember is that when I multiply fractions, if I have 1/2 and I was going to multiply it by let's say 3/7, sorry, that's a really bad 3. Let's say 3/7, well then what I'm going to do is I'm just going to multiply straight across. So this is 1 times 3, which would be a 3. This is 2 times 7, which would be a 14, and I would be done. So remember, to multiply fractions, we go straight across. To divide fractions, if I had 1/2 that was being divided by 3/7, that's where I have to keep, change, flip. So I will keep that, change this, flip that, and then multiply like normal. So again, those are skills that you learned last year, but you need to remember them because we are entering into these two problems. You have these two problems in your packet. Go ahead, draw your railroad tracks. And then ask yourself the question, what am I solving for? I am solving for this x. Then I have to ask my question, what is bothering that x? I look over here and I see that a -5/9 is bothering the x. So my next question is how? How is that bothering it? Well, it's bothering it by multiplying because they're right next to each other. So that is being multiplied by that. Then what I need to do is the inverse. The inverse of multiplication is to divide. So I'm going to divide both sides by exactly what's bothering the x. So I need to divide both sides by -5/9. I need to divide over here by -5/9. This will go away. It turns into the gigantic 1, and all I'm left with over here is the x. Then I just need to figure out what is that. So I need to take -15 and I need to divide it by 5/9. Excuse me, it's a -5/9. And then I know that in order to divide, I need to keep, change, flip. So I'm going to keep the negative 15 the exact same way that it is. Going to change the dividing sign into a multiplying sign. And I'm going to flip the 9 over the 5 and keep the negative sign. I know that a negative times a negative is a positive, so my final answer is going to be positive. I know I can cross reduce this because 5 goes into 5 once and 5 goes into 15 3 times. So now I have negative 3 times negative 9. Negative 3 times negative 9 is a positive 27. So that would be the answer for the first one. X equals positive 27. All right, so let's look at this next one. Same idea. What am I solving for? I'm solving for x. What's bothering that x? A 3/8. How is this 3/8 bothering that x? Well, mathematically, when they are right next to each other, they are multiplying. So my inverse would be to divide. So I need to divide both sides by 3/8. Whatever I do to one side, gotta do to the other. So I need to divide this side by 3/8. When I divide this side by 3/8, it cancels out, turns into the gigantic 1, and all I'm left with is x. Over here on this side, I've got a bigger problem going on, so I need to write it off to the side. Negative 2 divided by 3/8. Keep, so negative 2 stays. Change this to multiplication. Flip this around. And now I can multiply the fraction straight across. Negative 2 times a positive 8 is negative 16. 3 times 1 is 3. So you can leave it as negative 16 over 3, or you can make it negative 5 and 1/3. Either answer I will accept. All right, in those two blank spots on your packet, I want you to solve these two questions. Hit pause, show all of your work, and the next slide is going to show you how you did. All right, now that you've hit pause and you've come back, what you're going to see here are the answers to those two problems. The first one, you should have had negative 15. The last one, you should have had negative 35 over 6, which is the same thing as negative 5 and 5/6. All right, we've got a few more problems to continue on here. So what I want you to do is flip to your next page while I talk about this. Some people in the past have asked if the fraction could be on the bottom because they just haven't seen that before. Your steps are all the exact same, and you do not have this on your packet. But your steps would be the exact same. I would ask myself, what am I solving for? I would ask myself, what is bothering it? The 7/9. I would ask myself, how? How is that bothering it? It's bothering it by dividing. So the only other thing to do would be to multiply it by 7/9. So I'm going to multiply both sides by 7/9. When I multiply this side by 7/9, I would just go straight across. Now this isn't the greatest question because that's going to give me a very large number, which is 28, 2, 7, 8, 98 over 9, which could then be reduced, or not reduced, I'm sorry, turned into an improper fraction. What I want to do to make sure that you are following along is on your paper, I want you to write 98 over 9 in the margin over here somewhere, just so I know that you are following along with this. Just the 98 over 9. All right. Your next few examples deal with squares and square roots. Over here in the example, I want you to write what the inverse operation for a square is and what the inverse operation for a square root is. Can you remember? So the inverse operation of a square, I'm going to write square, and then I might just say is, and I put the answer here. What's the inverse operation of a square? And then down below it, I'm going to write the inverse operation of the other one, just to remind me. First thing here I'm going to do is I'm going to draw my railroad tracks just like everything else. I'm going to ask, what am I solving for? I'm going to say x, because x is what I'm solving for. What's bothering it is the squared. What's the inverse of a squared? Hopefully you put square root. So I need to take the square root of both sides. The square root of this cancels each other out, so all I'm left with is x. And the square root of 144 is 12. Technically, the answer is positive negative 12. We'll talk more about that later, because especially next year in 8th grade, it is going to be critical that you have both answers. In 7th grade, we really only focus on the one, the positive one. All right, so the second example you had, if I have a square root, I ask myself the same questions. What am I solving for? I'm solving for the x. What's bothering it? The square root. How do I undo that? I need to square it. Whatever I do to one side, I need to do to the other. Again, if you need to pause it because I'm moving too fast, please do that. Copy down what you need to copy down. And then come on back. All right. So then the squared and the square root cancel each other out, leaving me just with x. And 4 squared is 16. These two problems can also have a check done, just like we have for everything else. So you told me that x equals 16, and here's an x, and it originally, if I was to peel out the original problem here, said the square root of x is 4. Well, if x equals 16, is the square root of 16 4? Yes, it sure is. And same with up here. If I was to pull out this original equation, pull it off to the side, trying to make room, and we know that x equals 12, and I put a 12 in here, and then it told me to square it. Is 12 squared 144? Yes. I can't emphasize enough how important the checks are to help you be able to get A on this test. This should be the easiest test to get an A on. All right, your turn. In those empty boxes, I want you to fill in these two problems and hit pause. Then I want you to solve them and come back and see how you did. All right, for the first one, you should got a 16. Bonus points if you remember that it could be positive or negative 16. So if you remember that could be a positive or a negative 16, give yourself a little pat on the back. And the bottom one, x would equal 121. All right, we're coming up on the end of the video here. What I want you to do right now is take out that assignment from yesterday, page 72, and I want you to correct every single problem that is on here, and then mark that in your math packet. There are, what do we have? 1, 2, 3, 4, 5, 6. There are 18 questions on here, so you're going to have a total correct out of 18. I had some students come up to me recently saying, which homework assignments have I missed? Remember, the purpose of having that paper inside of your notes is that you won't have to ask me which assignments you've missed because you're recording them as you go along. All right, when you are done correcting this work, feel free. Well, don't feel free, you have to. When you are done correcting this work, make sure your name is on top of your paper. Also, the notes from class today that you've been writing on, page 27 and 28 in your packet. I want you to take both of those out, make sure their name is on them, your name is on them, and go put them into the turn-in bin and come back and start your homework, which is listed here. It is different from what is on the packet. I've added a few extra problems based on how quickly kids finished yesterday. I added a few extra problems for you to work on today to make sure that you are using your time wisely and appropriately. You need to have all of your work shown. If for anything you have not had your work shown or past homework assignments, if you finish early, make sure you use that time to get that done. If you have everything else done, make sure that you are either reading a book or you can go try one of the number puzzles that are in the bin. I have more coming, but at this point in time, that's all I have there for you right now. All right, thank you very much. Please continue to work hard for the sub, and best of luck on your homework. Make sure you show all your work.